Welcome to lecture series on data structures. In today's lecture series, let us discuss about the sorting algorithm. So the sorting algorithm that we are going to discuss today is insertion sort. It is also called as in-place sorting algorithm. So before we get to discuss about what insertion sort is all about and how does it works, let us have a brief overview on what is searching and sorting. So searching is all about locating an element in a given array or a list, or finding if the element is present in the given array or a list. This searching process is made easier when the elements in the array or list is arranged in a particular order, be it ascending order or descending order. So when the elements are arranged or sorted, searching process can be accomplished with a minimum amount of time. That is why we go for sorting. So to perform sorting, we do have several algorithms like bubble sort, selection sort, insertion sort, merge sort, quick sort, and many more. So each sorting algorithm works on a particular principle. So today we will discuss about what is insertion sort and how this insertion sort works. Let us go into the lecture. So here is a definition on what insertion sort is all about. This insertion sort is very much similar to playing a deck of cards. Everyone would have played a card game in your home, right? So this insertion sort works in the same way how we arrange cards in when we are playing. So we arrange cards within among themselves. So right. Similarly, here the elements are sorted among themselves. No additional array is required. So that is why this algorithm or sorting is called as in-place sorting algorithm. So now remember, now just let us have a quick recap on how we play the card game. So a particular person will receive a card, one card at a time, and every time he receives a card, he arranges them in in order in his hand. So as the new card is arrived, the player or the person, what would he do? He would scan the card with the card that he has obtained with the card in his hand. So generally from left to right, he would be scanning and looking for the correct position to place a new card. So this is how insertion happens when a new card is arrived. So same way insertion sort works, and it is very efficient when it comes to smaller arrays. And if you are having an array of n elements, insertion sort starts with the array of 0 as started, and array of 1 is inserted into the correct position with respect to array of 0 and array of 1. So this insertion happens until all the elements in the array are sorted. So now look at this example. This is how insertion sort works. First compare the two values 25 and 57. They are in the correct position. Now 48 is compared. I mean 48 is the next value that is going to be inserted. Like 48 is a new card that the player has obtained. So already he has two cards in his hand, one with value 25 and other one with value 57. Now the player would scan the card with value 48 from left to right. So when he compares 48 with 25, it is greater than 25. So again he compares 48 with 57, it is lesser than 57. So he places the card to the left of 57. And the next card that arrives is 37. Again, the player will scan this card with value 37 from left to right. He compares 37 with 25, it is greater. Again, he compares 37 with 48, is smaller. So 37 is inserted to the left of 48. And again, when new card arrives, which is having value 12. Now 12 is compared with 25, it is smaller, so it is inserted as the first card. So this is how insertion happens every time a new value is inserted. So this shows the explanation of working of insertion sort. Assume you have an array of n elements where every elements is less than n. So if you want to place a new arrival, you have to search the array for subsequent sequentially until a key is found, which where the key value is greater than that of the new arrival. So call it as location J. Now make a space for the new arrival by moving the contents of A of J to A of J plus 1 and A of J to A plus J plus 2, A of J plus 2 to A of J plus 3 and so on. And new arrival is inserted as the element at location A of J. So this is the algorithm of insertion sort. So array comparison starts from I equal to 1 to array which I is less than array size. So this while loop, it is used for moving down one position when the value is greater than the new arrival. So if initial file is sorted, only one comparison is made on each pass. So the sorting algorithm has time complexity of order of n. Or in the other hand, if the initial array is sorted in reverse order, sorting will take order of n square time. So here order of n square refers to the total number of comparisons required. However, a simple insertion sort is far much better than the bubble sort. So the closer file is to be sorted, is to sorted order, the more efficient the insertion sort algorithm will take. So average number of comparison insertion sort takes is equal to order of n square. So here is a overview of sorting algorithms. Generally, the sorting algorithms are classified into two types. One is internal sorting and other one is external sorting. Under internal sorting, we have two major algorithms. One is bubble sort and insertion sort. So in today's lecture, we have seen about insertion sort and its working. Hope you understood the logic behind the working of insertion sort and why it is called as in-place sorting algorithm with the example of card example. In the next video, we will look at some other sorting examples like bubble sort, selection sort, quick sort, and merge sort, and how does it works, and some few more external sorting algorithms as well. Keep watching and thanks for watching this video.